Hi friends, today we are going to learn about lesson matter. We know that anything that has mass and occupies space is called matter. Steel, wood, sand, ice, water, and milk are all different kinds of matter. We use the word matter for all the things of the universe, whether it's living or non living. Our body is also made up of matter. An Indian philosopher, Maharishi Kannad, proposed that matter is made up of very, very small particles called Paramanu or atoms. Atoms do not exist independently in nature. They join together to form molecules. A molecule is the smallest unit of matter that exists independently in nature. Molecules combine together to form matter. They have all the properties of matter. A molecule can be monoatomic, diatomic, triatomic, tetratomic, and polyatomic. A molecule that has only one atom is called the monoatomic molecule. Examples are neon and argon. The molecule that has two atoms is called the diatomic molecule. Examples are hydrogen and oxygen. The molecule that has three atoms is called the triatomic molecule. Example are water and carbon dioxide. The molecule that has four atoms is called triatomic molecule. An example is phosphorus. A molecule that has more than four atoms is called the polyatomic molecule. An example is sulfur. Kinetic theory of the matter. The kinetic theory of matter attempts to explain the physical properties of matter in terms of movement of its particle. The postulates of kinetic theory of matter. The matter is made up of very, very small particles called atoms. The constituent particles of a particular element are identical in all respects. The particles of matter have spaces between them. The spaces between the particles are called interparticle or intermolecular space, or also called as void. The particles of matter attract one another with a force called the interparticle or intermolecular force of attraction. This force holds the particle together. It decreases with the increase of distance between the constituent particle of matter and vice versa. Note, intermolecular force is effective between the molecule only up to the distance 10 nm. This force becomes ineffective beyond 10 nm. The particles of matter are in continuous random motion, Brownian motion. It is because they possess kinetic energy. The rate at which the particles of matter move, or the kinetic energy of particles, can be changed by heating or cooling. The higher the temperature, the faster is the movement of particles, or greater is their kinetic energy. States of matter. Explanation based on kinetic theory. We know that there are three states of matter: solid, liquid, and gas. The matter exists in different states due to the difference in characteristics of particle of matter. The kinetic theory of matter explains their three states of matter in terms of movement of particles of matter and their kinetic energies. In solids, there is solid state. In solids, the particles, that is molecules, are closely packed. That is, intermolecular space is negligible. There is a very strong intermolecular force of attraction in solids. This force holds the particle together in fixed position. They cannot move from one position to the another. Due to this, they vibrate only about their fixed position. Hence, the kinetic energy of the particle of solids is minimum. Thus, the particles of solid are arranged in definite manner. This gives a definite shape and volume to the solids, and they are rigid and incompressible, and they have high density. Liquid state. In liquids, the particles, that is, molecules, are loosely packed or less closely packed than solids. That is, the intermolecular space in liquids is more than the solids. The force of attraction is weak in liquids, so it cannot hold the particles in fixed position. They move from one position to another within the boundary of the liquid. Hence, the kinetic energy of particles of liquids is more than the particles of solids. Their movement within the liquid gives the definite volume to liquids. They do not have fixed shape. They take the shape of the container in which they are kept. They can be slightly compressible and not rigid. They can flow easily. Gaseous state. In gases, particles, that is molecules, are very close, loosely packed. That is, the intermolecular space is much more than solids and liquids. The intermolecular action is weak, that is negligible in gases. Thus, the position of the particle and the spaces between the particles are not fixed. Due to this, the particles are free to move with the entire space available to them. Hence, the kinetic energy of a particle of gas is maximum. Thus, the particles of gases are not arranged in a definite shape due to this reason. Gas do not have a definite shape and volume. They are not rigid. They are highly compressible and flow in all directions. Difference between solids, liquids and gases. Arrangement of molecules in solids are very closely packed. In liquids, less closely packed than solids, and gases very loosely packed. Intermolecular space. Solids, least, that is negligible, and liquids lesser, and gases very large. The intermolecular force of attraction in solids are very strong, and liquids weak, and gases negligible. Movement of particles. Solids vibrate about their position, about their fixed position, and liquids move within the boundaries of liquid, and the gases move freely in all space available to them. Kinetic energy in solids are minimum, liquids more than solids, and gases maximum. The shape and volume. Solid have definite shape and volume. Liquids definite volume but no definite shape. In gases, neither the definite shape nor the definite volume. Compressibility in solids. Incompressible. Liquids slightly compressible, and gases highly compressible. Flow. Flow in solids, that is, cannot even flow, and in liquids can flow, and in gases can flow easily. Number of free surfaces. In solids, any number of free surfaces. In liquids, only one free surfaces, and number of free surfaces. In gases, no free surfaces. Change of state. The change of matter from one physical state to the another is called the change of state. The state of matter can be changed by heating or cooling during the change of the state. The exchange of heat takes place between the matter and surroundings. For example, water exists in all the three states, that is solid, which is ice, liquid, which is water, and gas, which is water vapor. Ice changes into water and water changes into wet vapor on heating. Similarly, water vapor changes into water and water changes into ice on cooling. During the change of state, the temperature remains constant. Let's discuss the phenomena involved in the change of state. Melting. The process during which the solid state changes into the liquid state at a fixed temperature on heating is called melting. Change of ice, which is 0 degrees Celsius, into water, same at 0 degrees Celsius on heating, is an example of melting. The fixed temperature at which a solid changes into its liquid state is called its melting point. The process melting can be demonstrated by the following activity. Aim: to show that the process of melting. Things needed: a beaker, a laboratory thermometer, a wire gauge, a tripod stand, a Bunsen burner, and some crushed ice. Method: take some crushed ice in a beaker and place the beaker on the tripod stand. Suspend a laboratory thermometer in the beaker so that its bulb is contacted with the ice. Start heating the beaker on a low flame. Note that the temperature of the ice when it starts melting. Note the temperature of the ice at a regular interval of 1 minute. Observation: on heating, you observe that the ice starts melting at 0 degrees Celsius. On further heating, the temperature of that ice does not rise until all the ice in the beaker gets changed into water. Thus, the melting point of the ice is 0 degrees Celsius. After melting of the whole ice, the temperature begins to rise again. Conclusion: that ice melts on heating and it's 0 degrees Celsius.